So now that we've developed the unit circle, we want to use this unit circle to evaluate trig functions. So how do we do that? Alright, so let's say we want to, for example, we want to find the sine of 2 pi over 3. What does that equal? Now one thing you have to remember is, when we developed it back here, unit circle, radius 1, remember that the sine is now the y coordinate. So that's one thing you got to remember. We now know that the sine of theta is the y coordinate and the cosine of theta is the x coordinate. And if you want to write that on your unit circle, that could be helpful. That when we have coordinates x, y, that is actually cosine of theta, sine of theta. So you got to remember that our x coordinates are cosine and our y coordinates are sine. Well, that makes this a lot easier, because if I have 2 pi over 3, and I just look around on my unit circle and I say, oh hey, here's 2 pi over 3. I go up to the coordinates, negative 1/2 and the square root of 3 over 2, and because I know the sine is the y coordinate, that means it must be the square root of 3 over 2. You know, if we want the cosine of 4 pi over 3, well, I go to my unit circle, I look for 4 pi over 3, and 4 pi over 3 is associated with the coordinates negative 1/2, negative square root of 3 over 2. However, I know cosine is the x value, so it is a negative 1/2. So the way that this unit circle works, I can ask you for the sine or cosine for any value on here, and you can figure it out because you know the x and y coordinate for each one. Now let's look at the other 6 trig functions. Let's say I want you to evaluate the tangent of 3 pi over 4. Now at first we look at 3 pi over 4. Where is that? 3 pi over 4 is right here. And we think, well, we have an x coordinate and a y coordinate, but we don't have the tangent. However, we can get the tangent from this, because we know that if we have the tangent of 3 pi over 4, that the tangent is equal to the sine over the cosine. So the tangent of 3 pi over 4 is the sine of 3 pi over 4 over the cosine of 3 pi over 4. Now the sine of 3 pi over 4 is the y coordinate, so that's the square root of 2 over 2. The cosine of 3 pi over 4 is the x coordinate, so that's a negative square root of 2 over 2. And, well, square root of 2 over a negative square root of 2 over 2 is just a negative 1. So the tangent of 3 pi over 4 is a negative 1. What if we wanted to find the secant of 7 pi over 6? Okay. Well, 7 pi over 6, that's right over here. However, well, there isn't secant here. But we know that the reciprocal of secant is cosine. So we know the secant of 7 pi over 6 is the same as 1 over the cosine of 7 pi over 6. So let's see here. 7 pi over 6, the cosine is a negative square root of 3 over 2. So we have a negative square root of 3 over 2. And that ends up being a negative 2 over the square root of 3. And you can't have, so we have to rationalize that. So you get a negative 2 square root of 3 over 3. Let's try a couple more. How about the cotangent of 330 degrees? This probably won't happen too much, but it could happen. So we go to our unit circle. Here's 330. Okay, the coordinates are the square root of 3 over 2 over negative 1/2. But we have to rewrite cotangent. Well, we know cotangent is the reciprocal of tangent. So if tangent is sine over cosine, cotangent is the cosine of 330 degrees over the sine of 330 degrees. So the cosine of 330 degrees is the square root of 3 over 2. The sine is a negative 1/2. So we have the square root of 3 over 2 over a negative 1/2. And so that's going to be the square root of 3 over 2 times a negative 2 over 1. So it's a negative square root of 3. Good. Okay, so let's do a couple more problems based on these major points here. So for example, if you are asked for what is the sine of pi over 2, well, you go to pi over 2 and the sine is just 1. That's easy enough. Now there are these cases where what if we had the cosecant? What's the cosecant of 360 degrees? So we go to 360 degrees and the coordinates are 1, 0. Now you got to remember, what's cosecant? Well, cosecant is 1 over sine, so this is going to be 1 over the sine of 360 degrees. 1 over, so the sine is 0. Well, you can't divide by 0, so it's undefined. So in this particular case, the cosecant is undefined. And when we start graphing these, this will start making sense. Let's try another one. Let's try tangent. The tangent of pi over 2, well, that's the sine of pi over 2 over the cosine of pi over 2. Well, we got the sine, that was 1. The cosine of pi over 2 is 0, and it's another undefined. Okay. All right, so there are situations where you do get undefined, and that happens at these, 0, 90, 180, 270 points. So just kind of keep that in mind, it will happen. Okay, so now that we have this unit circle, one thing that has to also be discussed is, a couple lessons back I said, well, this is common knowledge. And common knowledge means that everybody knows it. So when you start taking classes of trigonometry and above, there usually is an expectation that these angles you understand and you know the x and y coordinates. So because of that, you do have to memorize this. Sometimes people are like, well, how do you do tests with trigonometry and not use a calculator? Well, this is it right here. Because once you memorize this unit circle, then you don't need a calculator. Because if on a test I ask you, well, evaluate the sine of pi over 3, you're like, well, that's easy. That's just the square root of 3 over 2. Done. So you do have to memorize this, and so oftentimes when you take tests in trigonometry and calculus, you don't get to use a calculator. And so when trig functions do come up, they give you values based on this unit circle because everybody just assumes that you know this unit circle. So please take the time to memorize this. There are patterns in this, so just kind of look for those patterns. Maybe in class I'll start showing those patterns. It does make it easier to kind of remember this whole unit circle.